Hello, uh, welcome to all of you. Now we discuss some VIVA question on numerical integration for paper CC14 Mathematics Honors. Why numerical integration is necessary over analytic integration? Is integration I equal to integration of limit a to b fx dx? Assume fx is continuous on the closed interval ab, then I exist, but analytical integration is not possible when primitive of fx cannot be calculated exactly, that is, anterior derivative of fx, that is equal to capital Fx, is equal to integration small fx dx, that is f dash capital F dash x equal to small fx. This example, integration e to the power minus x squared dx cannot be expressed in the terms of elementary functions. This equals to integration is this equals to 1 by 2 root over pi error function x. Or number 2, the function fx is not known, but the values of fx are known for at some number of points within the closed interval ab. Then numerical integration is necessary to find the value this integration value I. Next question, what is the difference between ordinary integration and numerical integration? Ordinary analytical integration depends on the fundamental theorem of calculus. Says, what is the fundamental theorem of calculus? If f is a continuous function on closed interval ab, and this capital F is an antiderivative or primitive of small f, that is capital F dash x equal to small fx, then integration a to b small fx dx is equal to capital ab minus fa equal to I is well-known theorem, fundamental theorem of calculus. On the other hand, for numerical integration, we approximate the function fx by an interpolating polynomial px and then integrate px between the limits a and b. And this is the basic difference between ordinary integration and numerical integration. What do you mean by mechanical quadrature? In mathematics, quadrature is a historical term for process of determining area. The process of numerical integration of a function fx of single variable x is known as quadrature or mechanical quadrature. Next question, what is difference between open and closed type mechanical quadrature formula? A mechanical quadrature or a numerical integration formula is said to be a closed type if the limit of integration a and b be taken as interpolating points. Otherwise, the formula is said to be an open type, that is, the point a and b are excluded. For closed type, we divide closed interval ab into n equal subintervals, each of length h, by the points a equal to x0, x1 that is equal to x0 plus h, and comma dot 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 x0 plus nh is equal to xn equal to b. With h equal to b minus a by n, this is the step length, by n plus 1 nodes x0, x1, dot 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 xn. And for open type, x minus 1 equal to a, x0 equal to a plus h, x1 equal to x0 plus 2h, comma dot dot xn equal to x0 plus nh equal to b minus h, and xn plus 1 equal to b. With this length of the subinterval is b minus a by n plus 2, and xi equal to x2 plus I equal to 1 to up to n. Next question, what is the degree of precision or accuracy? Very important question. The degree of precision or accuracy of a quadrature formula is the least positive integer k, such that the formula is exact, that is, no error, error free, for any polynomial of degree less than or equal to k, but there exists a polynomial of degree k plus 1 for which it is not exact, that is, error is non-zero, then this k is called the degree of precision k. Mention degree of precision of different types of quadrature formula. Newton course formula, this is the trapezoidal rule. This is the 2-point closed type Newton course formula, and this is the degree of precision is 1. And the Simpson's 1/3 rule, 3 points Newton's course closed type formula, degree of precision 3. Simpson 3/8, 4 points Newton course formula, degree of precision 3. Boole's rule, 5-point Newton course quadrature formula closed type, degree of precision 5. Ordel's rule, 7 points Newton course quadrature formula closed type, and degree of precision is 5. And this is the midpoint rule. This is the 1-point open type Newton course quadrature formula. This is the degree of precision is 1. And 2-point rule, this is the 2-point open type Newton course quadrature formula, degree of precision is 1. And 3-point rule, this is the 3-point Newton course open type formula, degree of precision is 3. Next question, why the trapezoidal rule is named after trapezoid, or describe the geometrical interpretation of the trapezoidal rule. Integration a to b fx dx, that is equal to it, t for trapezoidal, this is equal to h by 2 bracket fa plus fb. This is the area of the trapezium abcd. This is the curve y equal to fx, and this is the trapezium abcd. This point is a, this point b, so this height is fa and this height is fb. This is the x-axis, this is the y-axis. In trapezoidal rule, the curve y equal to fx, this curve y equal to fx, is replaced by a straight line joining the points a, this a point with coordinates small a comma fa, and this point b with coordinates b comma fb, and the area of the region bounded by xa, x equal to a, and x equal to b. The above line ab, this line ab, and x-axis, this x-axis, represents the approximate value of the integration a to b fx dx. It is so named as the value of the integration approximate by the area of the trapezium abcd, and this area is calculated by this h by 2. H by 2 is the h is this distance between the two parallel sides of the trapezium, and fa is the non-parallel side. This is the this is the fa is the parallel side length of these two parallel sides. Length of the two parallel sides length is this fa plus fb. Next question, what is curve replaced by the Simpson 1/3 rule? What rule of area calculation is also called a parabolic rule? Or what is the geometrical interpretation of Simpson's 1/3 rule? In Simpson's 1/3 rule, the curve y equal to fx, this is the curve y equal to fx, is replaced by a parabola. This is the bold type, this is the thick type, this is the parabola joining the points, this point A with coordinates a comma fa, this point B with coordinates a plus b by 2, this is the midpoint, this height f of a plus b by 2, this height, so coordinates is this, and this point C with coordinates b comma fb, and the area of the region bounded by x equal to a and x equal to b, and this x-axis. The above parabola and the x-axis represents the approximate value of the integral. Actually, what is the justification by this parabolic rule? This is the if the exact value integration a to b fx dx is approximated by integration a to b gx dx, where gx is a parabola, this type a0 plus a1x plus a2x square, this a2 not equal to 0, and then choose 3 points a, b, and c such that is fa equal to g, a plus b by 2, g a plus b by 2, fb equal to gb, and solving the above three for a0, a1, a2, we get this g a plus b by 2. So from this definition of gx, we get g a plus b by 2 equal to this, and gb equal to this. And for solving this a, b, c, So A0 equal to, in terms of FA, from solving this A0, A1, A2, we get this A0, A1, A2, and this. So integration is approximately equal to A to B gx dx. So integration A0 plus A1x plus A2x square dx. And so we get, after simplifying, we get B minus A by 6, FA plus 4 into F of A plus B by 2 plus FB. After putting the values of A0, A1, A2 and simplifying. So we can replace this fx by this approximate parabola, this integration by this parabola a0 plus a1x plus a2x square, and then we get this Simpson one-third rule. So this is the called parabolic rule. Different type of quadrature formula: closed type, trapezoidal rule, 2 points quadrature formula, and simple trapezoidal rule IT. Formula h by 2 fa plus fb is equal to b minus a, error term et is minus h cube by 12 f double dash eta a less than b. For composite trapezoidal rule, this is the formula h by 2 and error term etc, t for trapezium, c for composite, minus nh cube by 12 if double dash eta a less than b is equal to b minus a by n, and degree of precision is 1. Simpson's one-third rule, 3-point quadrature formula, number of subintervals n must be even, and simple Simpson's one-third rule is this h by 3 fa plus 4 into f of a plus b by 2 plus fb is equal to b minus a by 2, and error term for this Simpson's one-third rule is equal to minus h by h to the power 5 by 90 if fourth derivative beta where a less than eta less than b. For composite Simpson's one-third rule, this h by 3 fx0 plus fxn plus bracket fx1 plus fx3 plus dot dot plus fx in minus 1 plus 2 into bracket fx2 plus fx4 plus dot 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 fx in minus 2 bracket close and third bracket close, and error term for this composite Simpson one-third rule is equal to minus n h to the power 5 by 180 if fourth derivative beta a less than b is equal to b minus a by n, and degree of precision is 3. Degree of precision 3, and because this for third degree polynomial, this if fourth derivative is 0, so error term is 0. Simpson 3/8 rule, 4-point quadrature formula, closed type, number of subintervals, this n must be multiple of 3. So simple Simpson's 3/8 rule is this equal to 3h by 8. This for this coefficient 3 by 8, so this name is Simpson's 3/8 rule, and this fx0 plus 3fx1 plus 3fx2 plus fx3, and error term for simple Simpson's 3/8 rule is minus 3h to the power 5 by 80 if fourth derivative eta a less than b is equal to b minus a by 3. Degree of precision is 3. And for composite Simpson 3/8 rule, this formula ISC 3h by 8 bracket this, and error term for composite Simpson 3/8 rule is this minus nh to the power 5 by 80 if fourth derivative eta, and this Bool's rule, 5-point quadrature formula, number of subintervals n must be a multiple of 4, and this IB is the 4h by 90 bracket 7 fx0 plus 32 fx1 plus 12 fx2 plus 32 fx3 plus 7 fx4, and this error term in the Bool's rule, this minus 8 h to the power 7 by 945 a fourth derivative beta a less than b is equal to b minus a by 4, and degree of precision Bool's rule is 5. Euler's rule is the closed type 7-point quadrature formula, number of subintervals in must be a multiple of 6, and simple Euler's rules, this 3h by 10 bracket fx0 plus 5 fx1 plus fx2 plus 6 fx3 plus fx4 plus 5 fx5 plus fx6, and error term in the Euler's rule is minus h to the power 7 by 140 if put 6th derivative eta, and this, so degree of precision is 5. Degree of precision is 5. And composite Euler's rule, this is the formula, and composite error term for the composite Euler's rule is the formula. And different quadrature formula, open type. This open type mid-point rule, actually this is the 1-point quadrature formula. Very interesting. This is the only 1-point quadrature formula. Here number of subintervals 0. It is to be noted that the number of subintervals for this midpoint rule it is in number of subintervals 0, and this is the 1-point quadrature formula, and the formula is I equal to b minus a f of a plus b by 2, and error term is this, and degree of precision is 1. And for 2-point rule, this is the open type quadrature formula, and number of subintervals n is 1. This is the number of subintervals n is 1, and this x0 x1 is the 2-point. So this name 2-point quadrature rule. I is the formula, integration value, approximate value is this 3h by 2 bracket fx0 plus fx1, and error term is 3h cubed by 4 f double dash eta, and degree of freedom is 1. And 3-point rule, number of subintervals is 2. This 3-point rule, I is this 4h by 3 bracket 2 fx0 minus fx1 plus 2 fx2, and error term is this 14h to the power 5 by 45 if fourth derivative eta of this a less than eta less than b, degree of freedom is 3. Why is it called Simpson's 1/3 rule? Because of the factor 1 by 3, this h by 3. Simpson's rule is also referred to as Simpson's 1/3 rule. Next question, what are the difference between Simpson's 1/3 rule and Simpson's 3/8 rule? Which one is better for same number of intervals? Simpson's 1/3 rule is this is a 3-point quadrature formula. Simpson's 3/8 rule is a 4-point quadrature formula. And this formula is this, I is equal to this, and for this 3/8 rule, formula is this. And error term is this, minus h to the power 5 by 90, f of fourth derivative beta is this, minus 3 h to the power 5 by 80, f fourth derivative beta. And number 4, here the number of subintervals is even, and number 4, here the number of subintervals is a multiple of 3. If we use the same number of intervals for both Simpsons of 1/3 and 3/8, the Simpsons 1/3 gives more accurate answer. Next question, what are the advantages of the Simpsons 3/8 rule compared to the Simpsons 1/3 rule? The disadvantages. The disadvantages of 3/8 rule are following. The number of subintervals must be divisible by 3 in 3/8 rule. The error constant c in the 3/8 rule, c is the 3 by 80. So error constant is 3 by 80 is the error constant, 3 by 80. 3 by 80 this is equal to 0.0375, which is much larger than the error constant c 1 by 90 for the Simpsons 1/3 rule. This is equal to 0.0111. So the error in the case of 3/8 rule is larger than the case of 1/3 rule. Next question, what is the rule for numerical integration if number of subintervals n equal to 5? Number of subintervals is 5, then which numerical integration rule you apply? You can use composite trapezoidal rule for n equal to 5. This number of subintervals number of 5, so the nodes are 6, x0, x1, x2, x3, x4, x5. So for this x0 to x2, these 3 points, so 2 intervals, we can apply Simpson's 1/3 rule for x0 to x2, and for x2 to x4, we can also apply the Simpson's 1/3 rule, and this x4 to x5, we apply trapezoidal rule or any other suitable combination. So for a number of subintervals n equal to 5, for this 2 subintervals x0 to x2 and x2 to x4, we apply Simpson's 1/3 rule, and for x4 to x5, we can apply trapezoidal rule or other. What is advantage of open type quadrature formulas? The only advantage of open type formulas over those of the closed type is when the function is difficult to evaluate or have an infinite discontinuity at the endpoints a and b. So this is the only advantage this formula over the closed type formula, open type formula. And actually, we exclude these 2 points, endpoints, this a and b. State the number of subintervals for the following quadrature formula. The Simpson's 1/3 rule and n must be even number of subintervals in here. 3/8 rule n is multiple of 3, Boole's rule n is multiple of 4, Woodall's rule n is multiple of 6, midpoint rule n equal to 0. Very important. This number of subintervals is 0. And 2-point rule number of subintervals is 1, and 3-point rule number of subintervals is 2. This completes this for numerical integration, and thank you for watching this video.